latitudinal ranges from the most northerly continuous range of white spruce through aspen, birch, jack pine, balsam fir, from 60 degrees down to 35 degrees through the more temperate species. And here's the latitude of our two sites. So these species are all native here, but the temperate ones are much further south normally, and the boreal ones are common further north. And we're really asking whether the more northerly species will be at a disadvantage with warming. And we're focusing on effects on two critical life history stages: germinate establishment from seeds, and juvenile growth and survival of plants both that emerge from seeds that we put in the field and from seedlings that we planted. Just a few shots. We planted 10,000 seedlings in 2007 of these. The 10 native species. We also planted buckthorn. Don't throw tomatoes at us. The reason we planted buckthorn is that we did this at the behest of the DNR's invasive species manager, who wanted us to do this. Buckthorn's already here. It's already established in northern Minnesota. It hasn't gone wild yet like it has in the southern part of the state. It may with warming. And so we wanted to test whether a few degrees warming would really help buckthorn competitively compared to the other species. We're going to remove them all before they become reproductive. Just a few shots. This is the open area at Cloquet. This is a major technological endeavor. Luckily, I have very talented postdocs and technicians to help build and implement this. But anything you do on 96 plots with high technology is a lot of work. Just a few shots of the things being assembled, the control boxes being moved to the field, arrayed. This is actually at near Fall Lake. Put into the field, the site's established, lamps put up. And here's our 10,000 seedlings we planted. This is from late 2007. They established very well. You can see most of these different species here. Another shot of a different plot. So we were lucky. It was cool and moist that spring, so our planting went very well. We also plant 60,000 seeds every year of the same 11 species. So look at how well they establish from seed. We don't keep track of every single seed, but every single seedling is barcoded, so we can keep track of it without having to write anything down in the field. And a shot of one of the lamps. Well, our treatments work. This is just to prove this. This is the average temperature of above ground plants at Cloquet and here on Fall Lake, in the open in the understory. Treatments actually average around 1.8 and 3.6 degrees Celsius. The soil temperatures were very similar, a tiny bit higher than this. So the treatments work. We're able to create temperatures that are a couple degrees warmer Celsius, which is about 3 degrees Fahrenheit, and double that. So we have 3 treatments: no warming, 3 degrees Fahrenheit, 6 degrees Fahrenheit. And our overarching hypothesis is simply that warming will enhance the growth and survival of the temperate species that are already at the cold edge of their range, but reduce the growth and survival of those boreal species that are already at the warm edge of their range. And the mechanisms get a little more complicated. In science, the devil's always in the details. We expect all of these and others to, in aggregate, impact what happens. The first is altered phenology, which is just the timing of leaf out and leaf drop and flowering and the like. That, not surprisingly, in a warmer world, we expect earlier leaf out and delayed senescence, but perhaps differences among the species. Second is direct effects of physiology. It's cold here for plants in, maybe not today, but in May and June and September and October. Warmer temperatures should allow them to photosynthesize and be more productive. Again, maybe the maples and oaks should do this better than spruce and fir. The wild part is that in a warmer world, even with the same amount of moisture, you lose more water from plants and soils, and therefore it gets drier. And we expect more frequent and more severe drought stress. Because our soils are infertile, one of the reasons our soils are infertile is it is cold most of the year. Warming, if it's wet enough, should increase nutrient cycling and make these soils more fertile, more productive, which again might favor faster growing temperate species. And last, and very unpredictable, is that in the spring and fall, unusual cold snaps can kill the temperate species. So maybe they come up before climate warming, maybe red maple or burro would grow in southern Manitoba, grow fine for 12 years, then a really cold snap in the spring or fall would kill it. In the future, we don't really know what's going to happen to the timing of those cold snaps, whether they will be more of them or less of them compared to the shift in the overall climate. But we do expect there'll be changes in the frequency of extreme cold periods in the spring and fall that might kill the more temperate species. Well, what did we see so far? Even last year, in the first year, we saw, surprisingly to us, evidence right away of impacts on all these things. Phenology, the timing of leaf out, leaf drop, growth, survival, photosynthesis, which is carbon gained by the plants or energy gain, and frost damage. But I want to just show you a picture here. This was mid-May last year. Which plot was warm and which is not? It's pretty clear which one was. There's a big increase, and I'll show you this one slide here. The red is the ambient, the green is plus 2 degrees C, the blue is plus 4. Just look at balsam fir. This is the day of year. 150 is around June 1st. Balsam fir, this is the percent of individual plant with their first leaf fully expanded or first needles. The red line here showed that mid-May balsam fir was producing new needles. With a couple degrees warmer, it was maybe 10 days earlier or 7 days earlier, and it was quite a bit earlier with the higher warming. All the species showed this kind of shift with some differences among species. So all the species did leaf out earlier, and they also kept their leaf later. Minnesota is one of the few places you can see as many as 3 seasons at once. This is last year in the fall. We had some snow. You can see some senesced fall coloration and some green leaves still all at the same time. And if you look at the warm plot, it was much less senesced and much less snow accumulation on it. And so this is emblematic of the fact that warmer world will change the nature of what happens when you have snow in the spring or fall, and also just shows the fact that our treatments did create differences in this time of year. So we see changes in phenology, and we don't yet know exactly what they'll mean. We also saw that when we look physiologically at photosynthetic energy gained by plants and their growth, that we thought that in spring and fall, when it's cool and moist, all species should prosper with warming, and in a wet, cool summer, because some of our summers are wet and cool, maybe all species would do well. But in midsummer, and or in summers that were generally hot and dry, that heat and drought stress would impact more on those true boreal species. This is our hypothesis. And the data seem to suggest this. It shows photosynthesis, which we measure with a fancy high-tech chamber on leaves. The blue are the heated plots, the red and ambient. And this is for August and September last year. Except for aspen and birch, all the species that we measured actually had higher photosynthesis when they were warm. So look at red maple, the blue bar higher than the red bar. Same with red oak. But the aspen and birch was slightly lower, the blue bar slightly lower than the red bar. And aspen and birch have higher rates of photosynthesis than the other species. That really isn't a good indication of their overall competitive ability. The relative shift in performance is what's important. This was in the wet time of year. In July, when it was really hotter and drier last year, all the species photosynthesis was doing more poorly in the warm plots. Look at red maple, blue versus red. But the 2 species that did the most poorly, that were most negatively affected by the warming and associated enhancement of drought, were the birch and aspen, are kind of fast-growing boreal species. And you can see there, this is on the unwarmed plots, and this is the warm plots for both of those species. The rates of leaf productivity were cut in half. So we see a lot of hypotheses being supported about the complex differences with time of year and species differences. But the bottom line, when we think of growth and survival, can be summarized here from last year, looking at both the establishment and survival of seedlings from seeds that were planted in 2007 and 2008, 2009, not 2007. And from the seedlings we planted in 2008. And that was that the growth and survival was lowest or most negatively impacted by warming in fir and aspen, pretty neutral in others, and highest increases in red oak and red maple. And so this is consistent with our thoughts that the more northern species will do poorly.